Hello. In this video, we want to look at some definitions. The first is the trigonometric functions. So if alpha is an angle in standard position whose terminal side intersects the unit circle at point xy, then sine alpha equals y, cosine alpha equals x, tangent alpha equals y over x, cosecant alpha is 1 over y, secant alpha is 1 over x, and cotangent alpha is x over y, provided that no denominator is 0. Now, the reason that this works is because you've actually already seen this before. If you're on the unit circle, unit just means 1. So each of these coordinates would be 1, 0, 0, 1, negative 1, 0, 0, negative 1. And notice that if we were to figure out the radius of each one of these, the radius at each one is 1. And even if you're somewhere in between, say right there, that radius is still 1. So r in those definitions of the trigonometric functions would be 1 and just kind of goes away. And notice that happens where the r becomes 1 there. Now, sine is the reciprocal of cosecant and vice versa. Cosine is the reciprocal of secant and vice versa. And tangent is the reciprocal of cotangent and vice versa. For periodic functions. Now, all trigonometric functions are periodic functions. If y equals f of x is a function and a is a non-zero constant such that f of x equals f of x plus a for every x in the domain of f, then f is called a periodic function. The smallest such positive constant a is the period of the function. Okay, so a periodic function basically means that it repeats itself, it cycles over time. And so what that means is that if you take a function value here, if you have the period of the function, if you add that or subtract it from this x value, there's going to be another point over here on the curve at the same y value at that distance of a there. So 2a, same thing, or negative a, same thing, negative 2a, same thing. So that's all a periodic function says. So periodic just means that it repeats itself over and over and over and over. Now, every sine wave, being sine or cosine, they're both technically sine waves, has an amplitude. So the amplitude of a sine wave, or the amplitude of the sine function, is the absolute value of half the difference between the maximum and minimum y coordinates. Now, there's another way of looking at this for amplitude. If you have a function itself, then if it's y equals a sine of x or y equals a cosine of x or something in that form, then it is just the absolute value of a. Don't worry about that extra vertical line there. It's just the absolute value of a. So this a out front tells us what the amplitude is. Now, the thing about this is that this should be very familiar to you. That a is very similar to the vertical stretch that we saw in 1414. Now, let's talk about how we find periods. So the period of sine of bx and cosine bx. So the period p of either y equals sine bx or y equals cosine bx for b greater than 0 is given by the period is equal to 2 pi over b. In other words, if b is negative, make sure you take the, there are actually some things we can do with a negative, but if it's negative, you just kind of think of it as an absolute value. But the period is 2 pi over b. And that's, of course, in radians. So if you needed it in degrees, the period would be 360 degrees over b. Okay, now let's talk about the general sine function. So we have two different possibilities here. If you have an a, or if you have sine, or if you have cosine. Now notice that what we see here is no different from the standard transformations from 1414. Remember, those look like y equals a times f of b times x minus c plus d. Notice that all of these are the same thing. And this is what we would consider to be standard form here. So notice that inside the argument, whatever the sine or the cosine is acting upon, you need to make sure that your period, your b, is out front. In other words, there needs to be a 1 in front of the x, a positive 1 in front of the x. And if there isn't a positive 1 in front of the x, we've got a problem. Now, this is a sine wave with amplitude a, period of 2 pi over b, where b is greater than 0, phase shift c. Now that c is very important. That's a new term here. So phase shift is whatever c is. And of course a vertical translation d. Now that vertical translation actually has some significance. D is going to be the average of all of the function. Because if you have sine or cosine, that vertical translation is going to be the average of the function. The vertical translation is upward for d greater than 0 and downward for d less than 0. The phase shift is to the right for c greater than 0 and to the left for c greater than 0, but it's not going to look that way, remember? If you have a negative here, that means it goes to the right, and if it has a positive, I guess for either one of those, it goes to the left. Okay, now one more thing. Frequency. Let's use a different color. So the frequency of a sine wave with period p is defined as f equals 1 over p, which is b over 2 pi. Okay, so the frequency is just the reciprocal of the period, and that's it. So b over 2 pi. Now frequency is very important. So b tells us two things. B tells us the period, and it also tells us the frequency, because those two things are interrelated. The period is 2 pi over b, and the frequency is b over 2 pi. Now the reason that this matters is because the period or the frequency of, say, light or something like that has whatever light you're seeing, the color of it is determined solely upon the frequency of the light, aka the period of the light wave. And as a result, that actually tells us how much energy is contained within that photon of light. And so the period and frequency actually are very important, especially for terms of, just light waves. Everything that we're talking about is extremely important, but that's extra important. All right. Well, I think that's it. Nope, that's not it. Awesome. Almost. Now, 5 key points. There are 5 key points for sine and cosine. And there are 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0, or their corresponding degrees for sine. For cosine, 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi 1. And their corresponding degrees. Now, here's the thing. Notice that the x's are the same for each one of these. It's the y values that are different. And the y values and x values just come from the unit circle. All of this is from the unit circle. So there's really no reason to memorize this anymore. You've already memorized this. Alrighty. So this coordinate here is 1, 0. This coordinate here is 0, 1. This coordinate is negative 1, 0. And this coordinate is 0, negative 1. Notice this is 0, pi over 2, pi, 3 pi over 2, 2 pi. And again, 0, pi over 2, pi, 3 pi over 2, 2 pi. Good. And the y coordinates are just the x or y values, depending on if it's sine or cosine. Sine is the y values, so 0, 1, 0, negative 1, 0, 0, 1, 0, negative 1, 0. And for the x's for the y's for the cosine, they are the x's. So 1, 0, negative 1, 0, 1, 1, 0, negative 1, 0, 1. Alrighty. Believe it or not, that is it this time. So I'm going to go ahead and end the video here, and I will see you in the next one. Have fun.